Hi, today I'd like to show you a system we're calling cluster groups. The use case is for actors that need individual sounds, but when grouped together and the crowd grows too large, the individual sounds become too chaotic and the voices build up too much. While the classic example for this is zombie hordes, this can apply to crowds in general. Today we're going to get a little creative and not use the zombie or people example. I'll spawn our actor, and we'll hear the individual sound trigger every time the orb expands. I'll spawn a few more actors, and we can see that the cluster group system places an emitter at the center of the group and the most left and right actors. I'll go ahead and spawn a few more actors. And as we move around the crowd, we see the center, left, and right emitters updating in real time. The system sends the number of actors to the sounds being played so they can respond to the size of the crowd and play the appropriate sound for the group. In this case, we're using an RTPC, but this system also works with Unreal Audio. In this example, the number of individual sounds cap out at 10, and a group sound begins to play from the left and right emitters based on the number of actors RTPC. I'll increase the actors to 25, and we'll hear an additional bed sweetener come in. Here we have a multi-mono stereo file where the left sound is assigned to the left emitter and the right sound to the right emitter. Let's use the average Z positions so that the emitters have a consistent height. And if we disable it, you can see the green emitters getting positioned at the exact locations of the actors again. Now enabled again, you can see the height remaining consistent with the average height of all the actors. We can also change the width to compress or expand the spread of the emitters. There's also an option to use the average position of the actors to the left and to the right of the center emitter. We'll go ahead and use the width to expand the spread a little. Now let's put the width back to 1, we'll disable the average XY positions, and we'll enable the move along boundary parameter. This allows for smooth transitions along the boundary of the group, avoiding snapping from one actor to another. With it disabled again, we can see the snapping effect toggling between actor positions. And now enabled again, we can see it smoothly traversing the boundary of the group. I'll increase the actors to 30, and we'll hear another bed sweetener come in that is assigned to the center emitter. The types of sounds here are completely arbitrary. You're free to decide the type of sounds to place at each of these emitters and how they blend and respond to the number of actors. In addition to tailoring the sound to the size of the group, we're also cutting down on voices piling up for each individual actor. As I reduce the number of actors, we can see and hear the system updating. I'll go ahead and add movement to show the responsiveness of the system. go ahead and use the average XY positions if we want to make it less reactive. I'll update the width a little. And now I'll go ahead and remove the average XY behavior. And as I reduce the number of actors and approach our limit to 10, we begin to return to only hearing individual sounds. I'll bring the actors down to 3, and I'll go ahead and set the position slew so that the emitters follow the positions exactly. That's it for now. For more info, contact us on our website, and we'll be happy to discuss the needs of your team. Thanks for watching.